Hello, this is Mr. Henry, and welcome to Lesson 6.1. Today we're going to be talking about solving inequalities using addition or subtraction. And so the center question just says, how do I solve inequalities using addition or subtraction? The get the goofs down here are all one-step equations, which we talked about way back in the beginning of Chapter 3. And so the way we solved all these equations is we were trying to get the variable by itself, and we had those 5 steps like getting rid of parentheses, combining like terms on each side, getting rid of adds and or getting rid of, if there's variable on both sides, getting rid of the one on the right, getting rid of multiply divides, then getting rid of adds and subtracts. Well, these here all have one step, so we just do that one step. So the way we get rid of this plus 2 is we subtract 2, these would cancel out, and we would get a positive 6. And number 2, the way we get rid of a times by 2 is we would divide by 2 on both sides. And 8 divided by 2 is not 16, it's 4. In number 3, we would, to get rid of a subtract by 9, or a negative 9, is we would plus 9. Plus 9, and these cancel out. And 23 plus 9 is not 14, it would be 32. And finally, number 4, r divided by 2. Well, the way we get rid of a divide by 2 is we times by 2. And so r would equal not 3, but 12. Okay? We have one vocabulary word for today. It is an inequality. An inequality is a math problem where the two sides are not equal. One side is greater than the other. If you remember when we talked about equations, we actually had 3 possible answers. We had answers, we got like x equals 3, where we had one answer. We had some problems where the variables canceled out and we had like 3 equals 9. So here we had one answer. This had no answer, or no solution we called it. And then we had other questions where the variables canceled out. We had like 5 equals 5. And this had all real numbers. Well, today we're going to see these inequalities. We're going to get some problems where the answer is not every number, but it's a bunch of different numbers. Okay? And so we're going to get this other type of problem here today, and you're going to see the solving of these is very similar to what we've done before. Now, in our vocabulary box, we also have this place called circle type. Let's go ahead and fill this out now, and then we will be able to use this information later on. So with our inequalities, we're going to actually have 4 different circle types. So let's start by writing down our 4 inequalities. So we've got a less than, greater than, less than or equal to, greater than or equal to. Less than or equal to, greater than or equal to. Okay, so those are the names of those symbols. Now, when we're talking about this circle type thing, when we're going to solve these inequalities, we're going to have to graph each solution on a number line. And we need to know, on that number line, do we use, it's either going to be a hollow dot or a solid dot. So let's just tell you right now, these two right here are both going to be hollow dot. It's going to look like just a hollow circle. So if we had our number line, we'd put a hollow dot like that at, say, 3. These two are going to be a solid dot. So if we had our number line, here the answer will be like 5, we'd put a solid dot at 5. Now, the reason why we have hollow dots and solid dots is in this problem here, this answer of 3, we were not saying that 3 is an answer. We're saying like everything less than 3 is an answer, or everything greater than 3. but not equal to 3. So this hollow dot is kind of like a force field blocking off the 3, saying 3 is not one of your answers. But when we have a solid dot, when we have this or equal to line, the solid dot tells you that 5 is one of your answers, because the answers could be equal to 5, or maybe less than, or equal to 5 and greater than. It may not make a whole lot of sense right now, but it will make a lot more sense when we go through a couple problems. So let's do that. So here we have just a little wordy problem. It says, the greatest number of marshmallows Donald can fit into his mouth at one time is 19. Okay? Use only this fact to write and graph an inequality that describes the number of marshmallows Donald can fit in his mouth. Well, if Donald can only hold, let's see, the biggest number he can fit is 19. So he can fit 19 in his mouth. He cannot fit 20, but he can fit 18 and 17 and 16. So he can fit anything from 19 down. So maybe we'll use M for marshmallows. The number of marshmallows is less than or equal to 19. It's equal to 19 because it says the greatest number he can fit in his mouth is 19. So he can put 19 in his mouth, and he could put 18 and 17 and 16, but he could not put 20. So it has to be less than 19, but it could also be equal to 19. Now let's see how this graphs out. The way that we graph a solution to an inequality, which, by the way, this is an inequality, the way I graph this, is I put my solution, this 19, in or around the middle. So 19 there. These other lines just get numbered normally. So bigger than 19 is 20 and 21. Smaller than 19 is 18 and 17. Now, here's where that hollow dot, solid dot thing comes in. My symbol is less than or equal to. If you remember, the or equal to's have a solid dot. So we're going to put a solid filled in dot at 19. Now, we want to shade M is less than. So we want to shade less than 19. Well, which way shows numbers less than 19? Be this way, to the left. So the way we'd show our answer here is we just kind of bold in this side. So everything that's shaded is an answer. So 19, 18 and a half, 18, 17.9, all those numbers, even in between the lines, are answers. And we bold in this arrow over on this side to show that this keeps going. 16 is an answer, and 15, 14, and everything we can't show on the number line down here is still an answer to this inequality. Okay, so the type of inequality tells you the type of dot, and when you read this, the answers are numbers less than 19, so you shade less than 19. Now, I'm going to show you a trick to graphing these inequalities, to telling which way the arrow goes. You can definitely use the trick that I just used, or the strategy I used, just saying M is less than 19, so you shade the numbers less than 19. But a common shortcut I found that works is, now this will only work if the variable is on the left-hand side. The variable's on the left, this works. Think about this inequality as an arrowhead, and it's pointing this way. Guess which direction we shaded? That way. So let me see. So, see the inequality? The arrowhead's kind of pointing that way, so we shade that way. That trick works every time you have the variable on the left-hand side. If the variable's on the right-hand side, we'll do something different later on to fix it. But that's just a little trick you can use for now, and keep it in mind because we'll be using that from time to time throughout this entire chapter. Letter B. Letter B says the lowest temperature in January was negative 15 degrees. We want to write and graph an inequality that describes the temperature in January. Okay, so the lowest temperature was 15. So just write out some possible answers. So negative 15 is an answer because that was the lowest temperature. Can I have negative 16? No, because that's too low. The lowest was negative 15, and then you have negative 14 and negative 13, and anything higher than that. So when we write out our inequality, T for temperature, the temperatures were bigger than or equal to negative 15. They're bigger than negative 15. I mean, you could have had a temperature of 25 in January, or 40, or 90. It doesn't really say. It just says the lowest temperature was negative 15. So this is our inequality that matches this information. Now to graph. We put our answer at or around the middle. You're not always going to have a number line with 5 lines. Sometimes there might be 6 or something like that. So just put it near the middle. So there's your negative 15. Now, what type of dot? Hollow dot or solid dot? It's going to be solid because it has this or equal to line. So we're going to put a solid dot here. Now, which direction do we shade? Well, you can use both strategies here. First off, read it correctly. It says t is greater than negative 15. So we're going to shade greater than. Speaking of which, we didn't put numbers in our number line. We don't know which way is greater than yet. So let's go ahead and put their numbers in here, and then we'll go through and do the shade. So this is negative 15. What's bigger than negative 15? If you're thinking negative 16, you're wrong. If you remember, when we're talking about negatives, the more negative a number is, the smaller it is. So negative 16 has more negatives than that, so it's actually smaller. And negative 17 is even smaller. Negative 14 is bigger, negative 13 is bigger, and think what happens if you keep going this way. You get negative 12, negative 11, 10, 9, then you finally get to 0, and then positive 1, positive 2, positive 3, positive 4. So those numbers going this way are bigger. These numbers going this way are smaller. The trick here is remembering with the negatives, you almost kind of have to switch the numbers around from how you're used to thinking of it. Negative 14 is bigger than negative 15. Okay? So now that we have our numbers, now we can do our shade. So this says we want to shade numbers bigger than negative 15, which would be this way. There. Now, the other trick we looked at was the arrowhead trick. Now look at this. The variable is on the left-hand side, which is good. This inequality looks like it's making an arrowhead pointing that direction. See it? So we shaded that direction. That's the inequality trick. It only works if the variable is on the left-hand side. Let's continue. Now this next problem, letter C, I'm going to have you try this one. So copy it down on your paper, pause the video, try it on your own. Write the inequality, graph it, see how far you can get. Hit play when you're ready to continue, and we'll go through it together. Okay, it says here, Addison can bench press up to 94 pounds. Write and graph an inequality that describes the amount that Addison can bench press. So the first thing I would do is I'd write down some possible answers. So this kid can bench up to 94 pounds. Could he bench 95? No. Could he bench 93? Yeah. He can bench anything up to that. I mean, this kid could bench 1 pound if he really wanted to, or 5 pounds, or 23 pounds, or 92 pounds. But he cannot bench higher than that. So our inequality, maybe we use B for bench press, our inequality, our answers, the things he can bench press, is anything less than 94. Can it be equal to 94? Can he bench press that? He can bench press up to 94 pounds? Yeah, he can bench press that. So now we have our inequality. We put this number, our answer, at or in the middle. There's 94. To the right is getting bigger. We're positive, so just get bigger. Bigger than 94 is 95 and 96. And down this way you got 93 and then 92. We need a solid dot because we have this or equal to line. And which direction do we shade? It says B is less than 94. These numbers are less than. Using the arrowhead trick, it looks like an arrowhead facing that way. See it? Facing that way. So we'd shade that way. Both ways we did it told us we're going to be shading to the left. And that's what we have. So we wrote the inequality, we graphed the inequality. I have 3 problems from the textbook I'd like you to try. These come from page 157, numbers 1, 2, and 3. Number 1 wants you to write the inequality and graph it. Number 2 and 3, all you have to do is look at that picture and write out the inequality that would be that picture, would be that answer. Okay? Go ahead, pause the video, try it on your own, see how far you get. When you're ready to continue, hit play, and we'll go through it together. Okay, so let's see what we got here. Number 1. Lowest temperature recorded in Antarctica was -129 at the Russian station, blah, 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 blah. Okay, using only this fact to write an inequality, write and graph an inequality that describes the temperatures in Antarctica. Okay, so, well, it says that's the lowest temperature was -129. So we know -129 happened. We know lower than that, -130, did not happen because that one's the lowest. But bigger than that did happen. So the inequality, maybe I'll use T for temperature again. Temperature was bigger than or equal to -129 because it was equal to 129. It's bigger than 129, but it is not less than that. So we have T is bigger than or equal to -129. Now, you don't have a number line, neither do I. Here's what I do. 1, 2, 3, 4, 5. I just make it look like the other ones we had up here. I just make a number line, put 5 lines through it, and go to town. We get -129 in the middle. This way is getting bigger. So -128, -127, smaller, -130, -131. We need a solid dot because we have or equal to. And we need to shade to the right. How did I know to the right? 2 reasons. First off, because these numbers are bigger, and this says T is greater than that. And also because of that arrowhead trick. If you draw an arrowhead in here, that way is the direction we shade. So that's number 1. Now number 2 and 3 I can fit over here. So 2, 3. Alright, number 2. So first off, we just need our variable. So we'll call it x and something 8. I know it's 8 because that's where the dot is. So x is something 8. Okay, so let's look at this. The shading that way. So let's use that arrowhead trick in reverse. If we're shading that way, we'd use that symbol, less than. You're shading numbers less than 8. This is the less than symbol. Kind of looks like an L. L less than. So we're shading numbers less than 8. Is 8 included in our answer? Are we shading numbers equal to 8? No. So we do not need that other or equal to line. X is less than 8. That's the answer. Number 3. Okay, x is something to -2.5. Well, we're shading numbers bigger than, so we shade numbers greater than. So this is greater than -2.5. Also, the arrowhead trick, we're pointing that way, so we shade that way. Now, is -2.5 included? Yes, because we have this solid dot here, which means we need the or equal to, because -2.5 is one of the answers. Now, the rest of the lesson here today is, for the most part, solving these guys. So let's just get to it. These are all going to be one step using addition and subtraction. Fairly easy. So here the variable is being subtracted by 12. So just like before, the way you get rid of a minus 12 is you add 12 to both sides. We get k is less than or equal to, the sign stays the same, a positive 8. So you got 8 getting bigger, getting bigger, getting smaller, getting smaller. We need a solid dot, because we have or equal to, so we put a solid dot at 8. And which direction do we shade? Well, the arrowhead is pointing to the left. Think about this as an arrowhead pointing this way. So we shade this way. The grown-up way of doing it is you look at this and say, okay, this is numbers less than 8, because it looks like an L, less than. So you shade numbers less than. Letter B, P plus 8. Okay, so the way you get rid of a plus 8 is you subtract 8 on both sides. These cancel out. Those canceled. And we get P, and 10 minus 8 is 2. So we put 2 in the middle, getting bigger, getting bigger, getting smaller, getting smaller. We need a hollow dot because it does not have that or equal to. So this is numbers not including 2. 2 is not an answer to this question. Now, if you were trying to work ahead and you started shading this way, you're wrong. This is not correct. Do not shade this. Because my variable's on the wrong side. You cannot use that arrowhead trick if the variable's on the wrong side. The variable has to be on the left, the side that we like to see it on. So this is wrong. So how do we fix it? Well, the way that I like to do this is I prefer to have the variable on the left-hand side. So I'm going to take this inequality and I'm going to flip-flop. So I'm going to switch the P and the 2, but it's not good enough just to switch those two things. Do you see how this is kind of like opening towards the 2? Think of it like an alligator. He wants to eat the 2. Well, if you switch sides, he still wants to eat the 2. So it still has to face that way, towards the 2. So you flip-flop the two sides, the P and the 2, but you also have to change the direction of the inequality. Now we can graph. Now look at this arrowhead. It's facing to the left. P is less than 2. These numbers are less than 2. So this is our answer. So this is the first time we're learning about when we have to change the direction of the inequality. We change the direction of the inequality if the variable is on the wrong side. There will be another time, another section or two when we learn to change inequalities as well. Let's continue on. Letter C. T minus 12, well, we get rid of it using a plus 12. Plus 12, these cancel, and we got T is greater than or equal to 18. So we got 18 and bigger and bigger and smaller and smaller. Why did I put a negative? All right. Now, hollow dot or solid? Well, we need a solid dot because it's or equal to. And which direction do we shade? Well, we need to shade greater than, because T is greater than 18, and also that arrowhead trick. It's pointing to the right. See, it's pointing this way, so we shade this way. Letter D. W plus 7. Well, the way we get rid of this is we subtract 7 on both sides. These cancel. W. And this gives us a negative 16. Now, you see a problem here. Hopefully, the variable's on the wrong side. So let's just go through and switch it now instead of having to worry about switching it later. As soon as you see the variable's on the wrong side in your answer, flip-flop that thing. So we're going to switch the w and the negative 16. Now look, it's opening towards the w. So when you switch the sides, it has to open towards the w still. So you switch the sides and you change the direction of the inequality. Now we can graph from this one. So we put negative 16. Now, bigger than negative 16 would be negative 15, negative 14. These are bigger because they have less negatives. These are smaller because they have more negatives. Now, dot. We need a hollow dot because there's no or equal to. Negative 16 is not an answer to this inequality. And we need to shade greater than, greater than. It looks like an arrowhead pointing to the right. We shade to the right. And that is the answer for letter D. So what you should have learned so far, you should understand how to use the different circle types, the hollow dots and solid dots. Solid dot happens when you have this or equal to line, like right here. That's when you say shade a solid dot. You should understand how or which direction to graph the inequality. Do we shade to the left or to the right? We shade to the left when we have a less than, like here. This is a less than. We shade to the left. Also, you could use the arrowhead trick. It looks like an arrowhead pointing to the left. We shade to the right when we have a greater than, like here. This is a greater than. So we shaded greater than numbers, and it also looks like an arrowhead pointing to the right. I would like you to please do these 4 problems, E, F, G, H, copy them down, try them on your own, pause the video. When you are ready to continue, hit play, and we'll go through them together. All right, let's see how we've done. The way we get rid of a minus 9 is we are going to plus 9 on both sides. So these cancel. We get h is greater than or equal to 21. Alright, so we got 21, 22, 23. These numbers are bigger. 20, 19. Smaller. Just like a normal number line. They always get bigger from left to right. We need a solid dot at 21 because we have this or equal to. And we're going to shade to the right. Looks like an arrowhead pointing to the right. We're going to shade numbers greater than 21. Both reasons tell you to shade this way. Letter F. Let's see, p plus 4. Well, the way we get rid of a plus 4 is we subtract 4. These cancel out. P is greater than 6. So we put the number in the middle, getting bigger, getting bigger, getting smaller, getting smaller. Here we need a hollow dot because we have no or equal to. It's just greater than. And shade. Well, we're going to shade numbers greater than 6. Those numbers. The other way you can tell if you use the arrowhead trick is it's an arrowhead pointing that way. So we shaded that way. Letter G. G minus 5. Well, the way we get a minus 5 is we plus 5. These cancel out. Plus 5. G is greater than 20. Yeah, I can math. Variable's on the wrong side. We want to change this right now so it doesn't confuse us later. So we're going to flip-flop the G and the 20 and change the direction of the inequality. So G on this side, 20 on that side. Now it's opening towards the G, so it's opening towards the G. This is the one we want to graph from, because this is the one where the arrowhead trick works for us. So I put 20 in the middle, 21, 22, those are getting bigger, 19, 18, those are getting smaller. We need a hollow dot at 20 because there's no or equal to line. And we're going to shade to the right, because it's an arrowhead pointing to the right, or numbers greater than 20. This is the greater than symbol. And that's letter G. Finally, letter H, W plus 13 is less than or equal to negative 4. Well, the way we get a plus 13 is we minus 13. These cancel out. W is less than or equal to negative 17. The variable is on the correct side. So we're going to put the negative 17 in the middle. These numbers are getting bigger. So bigger than negative 17 is negative 16 and then negative 15. Getting bigger, closer to 0. Negative 18 and negative 19 are more negative, so they're smaller. We need a solid dot at negative 17. And we're going to shade to the left. It's an arrowhead pointing to the left, or numbers less than or equal to negative 17. These numbers are less than negative 17. Alright. So that's, in general, just solving one-step inequalities. The last thing we've got to look at here is a couple little wordy problems. So let's see. It says Tim must be at least 42 inches tall to go on the roller coaster. Okay. Tim is currently 38 inches tall. Find the possible height in inches that Tim could grow and be able to ride the roller coaster. Well, let's see. So maybe we'll use Tim, or we'll use H for height. So his height plus 38, because that's how tall he is now. So this is how much he has to grow. So he has to grow this much plus his 38 inches, and he needs to be at least 42 inches tall. So when you say at least, it means that tall or taller. So he can be bigger than 42, or he can be equal to 42. So let's think about this again. This is how tall he is now. This is how much he has to grow. And that's what his target height is. That's how I came up with these numbers. So how tall he is now, plus however many inches he needs to grow, has to be bigger than 42. Okay? Now let's solve this thing. And we're going to, well, subtract 38, because this is just an inequality now. So we minus 38 here, minus 38 there, and we get H is bigger than or equal to 4. Which you probably thought about that when you first saw the problem. You're like, oh, the answer is 4. But the answer is not just 4. The answer is anything bigger than 4, because he could grow 5 inches and still be able to go on the roller coaster. He could grow 10 inches and still be able to go on the roller coaster. So the answer is not just 4. It's anything bigger than or equal to 4. And it doesn't say the problem, we have to graph it, so we're done. So we'll call this 4 inches. Find the possible height in inches that Tim has to grow and be able to ride the roller coaster. The answer is anything bigger than or equal to 4. Letter B. Sarah can carry up to 50 pounds. She's carrying a box that weighs 15 pounds. Find the possible weight that Sarah could still carry. Okay, so she can carry up to 50 pounds. That means she can carry 50 pounds, but not anymore. So maybe we'll use C for carry. So she currently is carrying 15 pounds. So 15 pounds plus some extra weight cannot be more than 50 pounds. It actually has to be, she can carry up to 50, so she can carry less than or equal to 50. So let's think about this again. So this is how much she's carrying now, how much more she can carry, and it has to be less than or equal to the 50 pounds total. That's how we came with our numbers. Minus 15 on both sides. These cancel out. She can carry anything less than or equal to 35 more pounds. Find the possible weight that Sarah could still carry. She could still carry 35 more pounds, and that would put her at exactly 50 pounds, and she can't carry any more than that. She can carry up to 50, but not more. Okay? The last problem I'd like you to try, this will be letter C. I'll read it to you. It says here, Yoda is no more than 900 years old. If he's been training Jedi for 500 years, at what age did he start training Jedi? Go ahead, pause the video, write your inequalities, solve it, and figure out how long he's been training these Jedi. Okay, so hopefully you did this on your own. Let's see here. Yoda's no more than 900 years old. If he's been training Jedi for 500 years, at what age did he start training? So his start training plus 500 years is no more than 900. So it's kind of less than or equal to 900. So start training plus 500 years. He's been training for 500 years. So let's see. So this is really kind of like a what we call a verbal model. So the start training plus he's been training for 500 years. We use some words and some math symbols. So we just maybe throw in a variable here. So maybe call it a t for training. Plus 500 is less than or equal to 900. We can solve this, guys. Subtract 500 on both sides. These cancel out. T is less than or equal to 400 years. So what age did he start training? He started training when he was someplace between less than 400 years old. So he maybe could have started training when he was 50 years old or 100 years old. Anything less than 400 years would work. Last two problems for the day come from the textbook, from page 358, numbers 7 and 8. Go ahead and try these two problems out. When you're ready to continue, hit play on the video and we will go through them together. Alright, number 7 says solve this and graph your solution. Alright, so let me just write down number 7 again. So y plus 5.5 is greater than 6. So to solve, we subtract 5.5, not 6. Subtract 5.5 from both sides. These cancel. Y is greater than 0.5. So now we graph. So you get a number line. 0.5 goes here. Well, since we got an answer of 0.5, I'm just going to count by that. So I'm going to count by halves. So 0.5, 1, 1.5. That's getting bigger. Smaller, we get 0, and then negative 0.5. We need a hollow dot because we do not have or equal to, and we're going to shade to the right. It's an arrowhead pointing to the right, or numbers bigger than 0.5. Either way you do it, you shade this way. That is number 7. Number 8 says, in example 5, which I've included here, this is example 5, suppose your bag weighs 29.1 pounds. Find the possible weight in pounds you can add to the bag. Okay. So you're checking a bag in an airport. Bags can weigh no more than 50 pounds. Well, if it can weigh no more than 50, it means it could weigh 50 or anything less than that. So it could weigh 50 or anything less than or equal to 50. So this is our bag. It could weigh anything less than or equal to 50. It's saying if our, now this is the old problem, if our bag weighs 29.1 pounds, how much more could we carry? Okay, so the 29.1 is our bag, plus some other amount, still can't be more than 50 pounds. Has to be less than or equal to 50. So now we just got to figure out how much more could we add to this bag. So if we subtract 29.1, x is less than or equal to, now I could probably do that decimal math in my head, but I'd rather make sure I get it correct. So 50 minus 29.1 equals 20.9. So we can carry 20.9 pounds more, or anything less. We could carry 1 pound more. It would still be okay. I could carry 5 pounds more, and it would still be less than 50. Because this is how much of our bag weighs now. I can carry anything up to 29.9 more pounds. Once I get to 21 pounds, now it's too heavy and I can't carry it anymore, or I can't put it on the plane anymore. And does it say graph? Find the possible weight to the bag. Nope, we don't have to graph it, so we're good. 20.9 pounds is our solution. The last thing is the summary. How do you know if the dot is a solid or hollow dot when graphing the inequality? So think about all those problems we did. How do you know if it's going to be a solid dot or a hollow dot when you graph the inequality? Think back, put down an answer, pause the video if you need to, and then hit play and we'll go through it together. Okay, hopefully you have some sort of an answer. The way you tell if it's a solid or hollow dot is based off the inequality. If you have, so I'll write sentences, if you have a less than or greater than, you get a hollow dot. If you have a less than or equal to or greater than or equal to, you get a solid dot. And that's what you should have had. You should have had something about the less than, greater than, get a hollow. The or equal to's get a solid. And that is the homework, page 359, numbers 6 through 24, evens. Thank you for watching. Bye-bye.